Okay, aha, there we go. Howdy, everybody. Welcome back. It's been quite a while since my last stream, um, but I am back. I've got some inspiration, and tonight we're basically going to be doing a GTK application, which is one of the primary things that I actually want to be working on. And like I said, we're going to be drawing hexagons. I've already had to do some of the heavy lifting. I spent several hours today working on some super boring things, like just basically getting a GTK app up and running, remembering or actually re-deriving how to use Cairo as the drawing environment. We'll get into a lot of that, but I'm not going to dive into the details. There's actually a lot of boilerplate involved, and most of it's both not very interesting and also kind of magical. Who knows if it's going to work? Also, as a quick test, I believe that I should now be, any chat that appears should now appear in the stream. Testing, testing, 1, 2, 3. And we'll see if it makes it over. Be pretty cool if that did happen. Oops. And that would be my cup of tea getting ready. I'm going to turn this off to make sure that my phone does not interrupt my music. Okay, it looks like the chat might not be appearing. Go back and mess around with the app just a little bit more. Chat. Doot, 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 doot. Okay, well, chat's not working. Don't know why. But if you want to chat, like, just head over to my Twitch stream, and I'll be keeping an eye on it. Anyway, let's get started. Where we are right now, I'm just going to go ahead and start my run loop. Cargo watch -x run. Hope that I don't have... Oh, yep. I don't know why I need a full recompile, but... Oh, right. I was clearing off space. I nuked almost all of my source code target directories. So as a summary, what we're starting out with is an application that just draws 7 circles on the screen, like basically in the middle of the screen in a hexagonal form. I'm going to count this a pretty big success if by the end of the stream I can, starting from an abstract map, position and draw hexagons corresponding to that map. And then it would be even better if I can figure out how to map mouse locations back. We're going to see that I'm pretty sure that's going to require that I remember and put together a whole bunch of linear algebra. By the way, hello Tanuja, welcome. So while this is compiling, I'm going to start out with some of the resources that I've been using for this. First of all, hex maps. There is this website right here, redblobgames.com or redblobgames.com. Whoever put this up apparently put the website up almost 3 decades ago and has been maintaining it. There is actually an absolutely huge amount of mathematics as applied to games of various kinds. It's incredible. I haven't even scratched the surface. I've only gone into the hexagonal grid system. And on this page, the author talks about, we're just going to jump to the top of the page here, talks about applying the geometry of various hexagonal maps as well as how to create a coordinate system for them, and includes a whole lot of... Oh, okay, we got a scammer already. Let's block you. I forget how. Let's see here. Hang on a second, I got a scammer in the chat. I know I had to do this last time and I've already forgotten how. Here we go. And getting closer. My machine is kind of struggling here. Yep. Just going to report them. Spam. There we go. Block them, close, cool. Okay. Alrighty, so back to this. So hexagonal grid systems. Now, I discovered this a few years ago. I implemented one of the hexagon grid systems. I'm going to be basing this application on that, but the grid system is really only going to be used as like a really an abstraction to determine sort of logical elements for the hexagon, or the logical elements that back the hexagons that we're going to draw. So I'm going to jump down because what we're working with, there's multiple systems, but what we're working with is called the axial coordinate system. It is designed to start from a center, and then the coordinates follow the q-axis, which goes along this green diagonal, and the r-axis, which goes along this blue horizontal. And I think I'm going to draw it this way. By the way, I can't actually recommend this website highly enough. The interactions that are on here are just incredible. And if I decide, like, just basically, for instance, as I mouse over things, it's highlighting the axes and pointing and like really drawing attention to what or how the coordinates change across them. But additionally, like, I can just decide that I want to rearrange them so that like the flat is at the top, and it's just incredible. I think for my purposes, I'm going to go with pointy. Let's see if that build is finally done. Last step. GTK takes forever to link. So in addition to just describing the coordinate systems, this guy goes through and like adds in algorithms. Like this one, we just want to figure out the algorithm for the neighbors for the coordinate system. Well, highlight one of the neighbors and it actually just shows relevant portions of code. This is an absolutely incredible place. I will go ahead and link this in the chat, but I'm also going to include it in the YouTube video when that goes up. Now, additionally, another resource that I'm using, this one is very important for figuring out how to draw a hexagon. Given a point and a radius, these are the formulas necessary to draw a hexagon. I have tried deriving this using entirely Cartesian coordinates. It's amazingly hard. This person, a mathematician, starts out with the, well, almost obvious of starting with polar coordinates, which are truly trivial, and then those are very easy to convert back to Cartesian. So this is one of the resources that I'm going to use tonight. And then finally, there's the chirographic system, which this one's pretty rough, but this is how you draw on a GTK drawing area. There we go. Okay, so the initial application, we've got it up. I actually went ahead and used these calculations to position all of these circles. I just positioned or drew circles based on the center. So like where this was the center, this white circle here, I then just used the formula for A, which would be a vertex here, and use that as the center for this circle. We're going to change that of course, because the point is to draw hexagons here. And let me make sure that I have the correct coordinate orientation. Here we go. Yes, things match up. Yep. Okay. So we're going with the pointy style. So let's see. To start out with, let's just change these circles into hexagons. So I'm going to load the code, main.rs. Now this code integrates quite a bit more with GTK than a lot of my previous code does. For instance, I've actually defined in a template file I've defined in a UI template file the actual user interface that we're working on here. Let's stop the program. Ooh. So let's see here, main.glade. So like I used a visual layout application to create this great big XML file, and then I just import it right along here, and then I actually inherit from the components in the file. There is, for doing this, for creating an actual full-on GTK component, there's a lot of boilerplate code. It's pretty hard to write, actually. I base it on another resource that I forgot to mention. We'll go to the GTK RS website where they have, here we go, this book. This book is, I think that it's considered incomplete, but there's a lot of stuff in here, like subclassing from existing components, as well as like the overall pattern, like implementing object class, adding this particular template operator to it in order to get additional stuff done, implementing the object impl, the widget impl, the button impl. I'm actually implementing an application, so it's a little bit different. We'll jump down. I actually do widget window and application window, and then apparently due to a quirk with how it's implemented internally, you have to have the private widget, or the private version on which you're implementing all of the internal functions that GTK might be calling for controlling the widget, and then you create your public class, which like defines the user interface that outside stuff will use for calling into here. At some future time, when I understand what's going on here better, I'll make a video on it, but we're going to focus instead for right now on some other things. Like for instance, once the private window gets constructed, I set up my event handlers. So one of them is the motion controller, which gives me the current mouse location. So every time my mouse moves, or at least when it moves over the component, I'm actually printing out the mouse location. I'm going to disable this for the moment because it's probably pretty expensive, and under the like streaming and recording and watching my own stream, it's pretty tough, or my machine is definitely struggling here. We're going to do a lot of our work right here in the set draw function. The drawing area, the drawing area, this is a GTK drawing area, this thing right here. It is, honestly, it's really not much more, it's not useful for much more than providing this set draw function. And then you fill it in, and at that moment you're working with a Cairo context, and that's where things get pretty tough. At least on the GTK side, it's undocumented. You've got all of these function names. You basically have to go over to the Cairo documentation, which hasn't really been, like, I'm not sure the library is still being updated. It's been a couple of years. But we'll go in here, keeping in mind that there are, in fact, a couple of additional functions that I'm using that I'm not really sure where they appear on the API, and like this is not very easy. But we'll start with a fundamental concept here, and we'll walk you through whoops, bring that back up. I'm going to walk you through set draw func. Here we go. How this works. All of the drawing is done with primitive functions that are on the Cairo context. This library is terrible for doing pixel drawing, and it's great for doing shapes and vectors and whatnot. In fact, I'm not even sure what function to use for pixels. I think ultimately I would end up using drawing circles that have a radius of 1. It's also extremely stateful. It's not like you're creating data structures and then feeding them to Cairo. You're like using functions to tell Cairo what to do in a very like turtle graphics sort of way. So in order to get this image, the very first thing I do is that I set the color to black, and then I paint the entire screen. That's one operation. It's now done. Nothing else in mind. Next, what I do is I set the line width, and I set the color, and I draw an arc. And then, very importantly, I tell Cairo to actually draw the stroke around the arc. And this is, I'm using I'm using the function arc because there is no function circle. But you can always get a circle by going from 0 to 2 pi radians. Stroke will take this data structure that's been constructed inside of Cairo or inside of the context and draw the path that's involved. So in this case, it's the perimeter. If I changed from stroke to fill, it would actually fill in. It would fill in this central circle, but I'm not going to do that right now. Once that's done, the active path or the active data structure is cleared out, and I'm basically doing the same thing over and over and over again. If I neglected to do this until later, I would actually get a weird extra extraneous line where the pen moves from this circle to this circle and then starts drawing that one. Nope, don't rebuild. I didn't actually change anything. Cup of Earl Grey right here. So, I hard-coded all of this. Let's start out with just one hexagon. How do I want to do this? I want to do it like this. It's going to be a little bit C declarative style. I'm going to call a function hexagon, and I'm going to give it the context, and I'm going to assume that colors and line widths and everything were set outside of the hexagon. And so instead, I'm just going to give it the current location. And this is going to be the location of the center of the hexagon. Drawing origin here. Wow. Yeah, okay, I am spelling that right. And let me give it the radius. Here we go. Okay, so drawing origin, this is just a constant that I defined for the center of the screen, or the center of the drawing area. Let's take, no, let's not delete this stuff yet. I will do my normal thing of commenting out code. Cool, there we go. And maybe just for the fun of it, we'll go ahead and draw the stroke out here. Okay, so now we need to write the hexagon function. Now, while I figured out how to do circles, this is going to be a new adventure because I didn't actually figure out hexagons. Pub fn, I don't need pub. This is just fn hexagon. we've got the context, which is, what is this data type? Okay, just context. Looks like I need to look that up so I can import the right thing. Cairo, double colon, context. Cool. Okay, I'm going to take two floats, so center x is an f64, center y is an f64, and then radius is also an f64. Okay. Coming back over to this one. This is where this gets involved. I want to start... I believe that the way to create a polygon with Cairo is using the path interface. We'll get to that in a moment. But I'm going to start... I know that I want to start the path with A. And for reasons that have to do with vector math that might get involved if we start looking at the mouse position, I'm going to go clockwise around this instead of counterclockwise. So we'll start out by figuring out the coordinate of A, which really is just figure out your radius, move over along x, exactly like that. So I'm just going to put the numbers right here, radius, comma, 0, which is actually offset. So it's going to be center x is plus radius, and then center y minus, or no, just center y. Okay, now let's figure out paths. Nope, go to the raw documentation. Just try to find a function that creates a path. Paths. Here we go. Oh, okay, cool. Create. Ah, here we go. New path. This is a C definition. The Rust definition is going to be reasonably similar. So I'm assuming it is context dot create path. Now let's find, or no, not create path, new path. Okay, I suspect new path takes no parameters. So I think once I've done new path, I think I want to move the cursor. Not realm. Begin a new subpath after given a current point of xy. Oh, that's not actually going to be useful to me, but it is interesting to know. Begins a new subpath. Call this after the current point. Okay. So we're going to do context.move2 x and y, and then so I just moved the cursor to point A. Now I want to move to point F. Do I? Hang on. There's like a screen inversion that happens here. If I have inverted things, I'm actually moving to B. Okay, I'm going to go counterclockwise around this, and the reason I'm going to do it is that once Cartesian coordinates and screen coordinates are flipped or inverted over the x-axis. So I think that going counterclockwise according to the math would actually end up being clockwise according to um, the screen. That might trip me up later when I'm trying to calculate whether a point is inside or outside. So context.line2, is that the right function? I believe it is. Yes. Okay, so starting at this location, I want to move to the next one. Wrong. There we go. So here we go. Location for B. X is going to be center X plus A over 2. A is my radius, so radius over 2. And then Y is going to be center Y plus 3. Oh, let's make sure this is a float, otherwise the math won't work. 3 as an F64 square root times radius over 2. Okay, now moving on to C. I'm just going to copy and paste. C, moving back along the x-axis, so this becomes minus the radius over 2, but the y remains the same. Then we're going to do D is easy. D is going to be minus the radius. So it's just a straight line. E is minus the radius over 2 minus the square root of 3, and then F is there, and then I want to close the path. Yeah. Okay, we'll save that. And the compiler is angry about this. Cannot find type context in Cairo, not found in Cairo. If you import context, refer to it. What? Oh, it is very confused. Oh, right, because I haven't actually included the Cairo library directly. Yeah, yes I did. Yeah, I didn't think that would work. What am I doing wrong here? We'll come back over. Here we go. Cairo, Rust. Wait, version 6. Whoa. This is version 16. Why do I have version 004? That's weird. Take off some of the version bounds. Oh boy. Something's weird. This is create Cairo. Crates.io. Cairo RS. What is this one about? Last updated 7 years ago. Yeah, okay. This is the one that we want. Gotta watch out for those crate naming conflicts. Try this again. Why do I have prop test? Oh, right, I use prop test in my coordinates library. Sweet. That's a hexagon. Do a quick comparison here. And I've drawn the wrong one. I need to rotate the whole hexagon. Okay, okay. That probably is not going to be hard. Is that really what I want to do? No, no. Maybe I'll just do this. Cool. Okay. So now, the next thing is instead of just hard coding all of the hexagons I want to do, I actually want to base them on the abstract map. Let's come back over here. I'm going to break this. You'll note that I am printing a whole bunch of stuff. Like, what is all this? Well, these are actually coordinates in the axial coordinate system. Everything within 3 spaces of the 0, 0 coordinate. And for reference, that is probably most easily demonstrated. Here we go, on this one. So, oh, whatever. Cube coordinates and axial coordinates are identical. It's just that axial doesn't include this S coordinate. But yeah, otherwise they're identical. So okay, this is the 0, 0 coordinate right here, the highlighted one. Then we get the first string out, so that's everything within radius 1, then radius 2, then radius 3. And currently, I am printing all of those. I think possibly just to maintain a bit of sanity, we're going to restrict ourselves just to radius 1 for the moment, because otherwise I could make a math mistake and end up with a drawing that I just cannot comprehend. In order to get the entire list of coordinates, just in this coordinate library, which I'll publish, but I mean, don't use mine. Go to this guy's website and like read the stuff and implement it yourself. It's really fun. But I grabbed the origin, which of course is 0, 0, and then ask it to list out everything within 3 spaces. I'll just comment that out. We're going to come back down to, where do I call hexagon? Here we go. All right, drawing area. So, for coordinate in axial adder dot origin, or origin dot within 1. We're going to draw a hexagon for each one of these. And in this case, we have to figure out where the center of the hexagon is. And since all of those centers are based themselves on a larger version of the hexagon, you can really say that like you've got this hexagon right here. The center of the hexagon above it is going to be 2 times this distance. So like take this, the distance from the origin up to the CB line is square root of 3a over 2. Just double that. So the center of the one above it is going to be square root of 3a over, or no, just square root of 3a. The way to calculate that with the coordinate system, though, Q does not change going up. Oh, which one do I want? Q doesn't change. R... Oh, yeah, okay. So R increments or decrements going up and it increments going down. Cool. So I'm going to take... Okay. So for drawing directly up, I want to draw... We're going up on the y-axis. So plus coordinate dot... Now let's actually figure this out. Center x equals drawing dot 0. Center y equals drawing origin dot 1. Okay, so for y, it's going to be drawing origin dot 1 plus 3 as f64 dot square root times hex radius over 2. And then all of this is multiplied by coordinate dot q. But I feel like that's not enough. Do I need to double this? No, maybe I just need to... We're going to draw that. We're going to see what happens. We're going to fix the syntax. Oh. There we go. That should be right. That's still not right. That's probably going to fail because Q gives an I32. It's always safe to convert from I32 to F64, right? Right? Huh. I'm not sure what just happened. Oh, I need to do the stroke after each one of them, and I'm going to go ahead and print. Should see. I know there's going to be a bunch of overlaps. Oh, wait, hang on. Q doesn't affect. There, R. There we go. That's looking pretty good. There's going to be some overlap because I haven't taken into account the Q coordinate. And in fact, I actually think that this is totally wrong. Like, it's great if I'm staying within the one coordinate system, but while this is while this one directly up has an r coordinate of -1, this one over at this angle also has an r coordinate of -1. So I'm not sure how I'm going to solve this. There has to be a way. Let me see, actually, if maybe, by chance, that is even included here. Pixel to hex. How do I take a pixel location and convert it into hex coord? Oh. Oh, that's pretty sweet. But it's not what I'm looking for at this particular moment. I want to go from hex to pixel. So for hex to pixel, size and spacing diagram. For axial coordinates, looking at the basis vectors, the arrow from 0, 0 to 1, 0 is the q basis vector that. Q basis star q plus r basis star r. Okay, okay. But that's for the pointy, flat top. Here we go. See, this is what makes the website so cool. Like, you make this change and like all of the code changes. It's incredible and I love it. Okay. So drawing origin plus, oops. So the size actually is calculated right in there. So hex radius, oh, let me make sure that I've got size right. Spacing, angles, well, I don't know how width is 2 times, okay, the size is the radius, good. That makes this easier. So, radius times 3 point divided 2 point. There's no square root involved. Oh, because I'm calculating out the center here. No? Oh, there's no square root on the x? Interesting. I'm not sure why that would be. Times coordinate dot q. And then this one, so for y, oh, right. No, no, still not sure. Okay, so y, it is the origin plus hex radius times 3 dot as f64 square root divided by 2 dot times coordinate dot q plus, ooh, I'll have to go back and actually study these formula and figure out what I'm looking at. That's f64 dot sqrt times coordinate dot r. That needs to be q, and I need to cast these all to f64. Compiler is happy. So we'll see what we get in just a moment. Oh, wow. Sweet. That worked. Let's take it out a little bit further. Let's take it all the way out to 3. Which, by the way, is the exact size of the board for the board game Photosynthesis. I believe also for Eclipse. Maybe even Twilight Imperium. Photosynthesis board game. Yeah, is this board game right here. Which, oh yeah, no, I don't want to go to Etsy. Is there a picture? Be better to be on Board Game Arena. So, while they're all drawn as circles, these are hexagons, and 4 to the side, you can see the 4 to the side here. So this is pretty cool. Once I got through figuring out the libraries, this is a lot easier than I expected it to be. So with that in mind, I'm going to save this where we are. Git add dot git commit. Draw hexagons based on coordinate system. Cool. Gonna take a little side trip now. I'm going to take another side trip now and start updating the canvas address field right here. Right now it's just this bunch of dashes, but I want to actually show the current mouse coordinates up in this area. So we're going to come back up to the motion controller here, and now I need to grab the canvas address. So we're going to see if this even works, actually. Let canvas address equal canvas address.clone, and we're going to move that in. Then canvas address dot set label. There we go. Format. What does set label take? Takes a string. X, Y. Now, I don't know that this is going to work because there are rules around cloning widgets and sending them to another thread, which I think callbacks are supposed to happen in another thread, but actually this looks like it's going to work. Okay, maybe it is fine. Okay, so there we go. It's ugly, but it is updating. Let's make it a bit prettier. Dot zero. I don't care about subpixels in this case. Yeah, that doesn't work. Is it colon dot zero? I don't want to look up the formatting. Take that away. Won't need it. Alrighty, there we go. Got the coordinates appearing in the canvas address. That was really quite simple. I'm going to stop printing the axial coordinates. Don't recompile. Okay. Now, that was simple enough. Let's do this mapping. Hex to pixel, we're going to do pixel to hex. Now this is pretty cool. I've never read this, so this is going to be new to me. how do I take a pixel location and convert it to a hex grid coordinate? So axial and or cube coordinates. For offset, you convert back to cube. Cool. So we invert the hex to pixel conversion. Oh. Okay. So it's actually like inverting these two. Okay. This is gonna be interesting because the author didn't take the origin into account the way I did. Maybe they did, actually. Come back to that part. So you multiply q and r by the basis vectors to get x and y, and then offset the x and y. We invert the pointy top hex pixel matrix to a pixel to hex matrix, except I'm doing flat top. Okay. We're going to get fractional axial coordinates q and r. Okay, so here we go. I'm going to say var q, let q equals 2 point divided by 3 point times x divided by hex radius. I think maybe these coordinates are assuming that 0, 0 is also screen display 0, 0. So I think I'm going to need to offset it. So x minus drawing origin dot 0. Okay. I'm missing a parenthesis somewhere. Okay, now let r equals 2 point, minus 1 point divided by 3 point times y minus drawing origin dot 1. Okay, good. Then divide that also by hex radius. And then I'm going to round those off. Let q equals, what does the axial round function actually do? Floating point, because this could be more confusing. Yeah. So I call this algorithm cube round, yeah. So you round each component to the nearest integer. However, after rounding, so this is for a cube coordinate where you're forced to guarantee that q plus r plus s equals 0. I use axial coordinates so that I don't have to deal with s. So axial round is, for purposes of axial round, it really does figure out. Ooh. Okay. That's, huh. This one, I think, is taking, let's see, what is the hex? The hex is probably gonna be the result of pixel to hex. This might actually be a step that I don't quite finish, but I'm going to try anyway. I'm just going to use a normal rounding function. Rust F64 round to I32. One would think that this would be trivial, but so many languages crashing through my head, and this one is complicated when it comes to number changes. Let's go to this. ToInt unchecked. Rounds to 0 and converts any... Well, that's sure not what I want. I'm in F64. Round. Oh. Okay, it actually is easy. Actually, instead of doing that, I'm going to do let coordinate equal axial adder q dot round r dot round. Check my API here. Yep, that's correct. So I also want to clone the, not the canvas address, what was this thing? Oh, the hex address. Alrighty. Everything looks okay. Let's run this. I'm worried that the rounding isn't going to be right because I'm doing a rather naive round here. Thought round was... Oh, it just gives back an F64. Well, then I think I can ToInt. Yeah, I'll do a ToInt unchecked. Oh, it is unsafe and requires an unsafe... Really? Fine. This is never how I solve problems. I'm solving it this way today. I don't even know if this is the right way to solve it. Coordinate. Okay. That's building. I sit back, drink some tea. There we go. It's drawing. Okay, so it's definitely calculating something. So according to this, I should be start with the geometry. Nope, not the geometry. I'm starting right here. I should be dealing with Q3 R0 if I come in from this side. So that's not correct. Yeah, there's some rounding complications right here. Because this is 1, 0, and this is 2, -1, when it should actually be 2, 0. But it's interesting. It's surprising how well I got there. So just for the fun of it, actually, first of all, I want to do a hex. Da, 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 da. So if the coordinate is outside of the hex map, I don't want to display it at all. So if coordinate dot, how does my distance function work? Measure the distance to a destination. So okay. If coordinate dot distance axial adder origin is greater than 3, then we're going to set the label to a default. Save that. Oh, that's not working. Oh, because I have to take a reference. And unnecessary parentheses. Fine, fine. I know that we've gone over the hour, but this is actually just too much fun. So I'm going to go a little bit longer here. So nothing, nothing, nothing. Ugh. Yeah, there's definitely some errors in my rounding code. But it is still enough. Yeah, this doesn't even show up. That's fun. But it's still enough to do the last step, which should be fun. So what I want to do now, there's there's 3 reasons to actually intercept, not intercept, to inherit from G object. One of them is if, well, in this case, it's like the most straightforward way to use an external scene description file for widgets. But another one, and the one that is relevant right now, is for the ability to add some private data that is not part of the standard widget, but that you want to track. So what we're going to do here is we're going to add current coordinate, which is an option axial adder. Let's see here. I need to find my new function. I'm not sure what's going to break now that I've added a variable that's not being instantiated, but we're going to leave that alone. Now, I want to, oh yeah, this needs to be editable, so make it an RC ref cell. I literally just learned about ref cells a couple of days ago. I'd been avoiding that. So save that. Why is that? Okay. I do expect compiler errors down here with my data structures. Because I'm not instantiating that, or I'm not initializing this. So we'll see what happens. But right down here, I want to Oh, it didn't fail. Okay, interesting. Let's see here. I want to let coordinate equal self dot, forgot what I named it, current coordinate dot clone, and then we're going to move that in, and in here, right here, so self dot current coordinate, or no, sorry, I've got a name conflict. I'm going to be lazy. Sorry, I'm giving it a one letter. Borrow mute. Equals some coordinate, or no, in this case it's literally none. And here it's going to be some coordinate. Save that, make sure all of that compiles, make sure it doesn't blow up. Because I think, yeah, if I, with a ref cell, if I borrow and it's being used somewhere else, it'll panic. But that should be okay at this moment. Okay. Yep, that's fine. Now, setting the draw function. Okay, if coordinate equals self.current coordinate dot borrow, and I'll have to then dereference it. I want to fill. Okay. Ah, right. Borrowed data escapes outside of associated function argument that requires one. Oh. Okay, okay. I'm going to do the same little cheat here too. Go ahead and clone the reference. And that should deal with the lifetime issue or the ownership issues. And well, it's certainly not perfect. In fact, I actually have it visually inverted. That's fun. Oh, there's a lot of errors in it. Still, that's pretty darn cool. Okay. Well, I'll fix the problems. Git add dot, git commit, back calculate the currently select or the currently moused over hexagon. Cool. That's pretty sweet. So I am going to, I basically accomplished everything despite the errors that are in there. So I am going to call it quits right there. I think that's a pretty good accomplishment for the night. As sort of a closing comment, I'm going to keep these going. I had to really think about it a while earlier today, but I realized that these sessions are actually really good to get me to really time box trying to solve a problem, because otherwise, like if I had been doing this without the time boxing, I um, probably would have yak shaved this for hours. And really, it's really cool that I was able to do this in just 1 hour, even though it took a lot of prep work just to get to the point where I could. Um, so yeah, I will keep these going roughly weekly, and I'll try to keep it all interesting. I may even try to build on this. Being able to have hexagons means that like hexagon-based games become possible, and that's pretty cool. Uh, so, on that note, it is 10:15 here. Thank you all for attending. I hope you enjoyed it. I will drop links to the resources in the YouTube channel or in the YouTube video description. Feel free to add any comments. And if there's anything in particular that you want me to work on, go ahead and let me know. I'm probably going to be focusing on GTK for the next several months. So especially if it's GTK based work, hey, let me know. Good night, everyone.